Okay. So I was asked to speak in English. I'll do that. I'm a bit sick, so this is not real. This is ski.
Yeah, that's
Feels like it. Okay, so my name is Boaz Zeniman. I'm a technical evangelist with the AWS team here in Israel. If you haven't seen me in previous sessions, in this meetup, in other meetups, so that's a bit about me and what I'm doing. Technical evangelist, AWS and other places are doing a lot of engagement with customers. This is my main role, is to meet our customers, talk to them about technology, how they can use our features, our services to create better products, improve their services. I'm doing a lot of events, a lot of meetups both here in Israel, helping the EMEA team, which I'm part of it. We are running a monthly series of webinars. We just finished yesterday a series of 7 webinars called Journey to the Cloud, which is 7 sessions of very basic webinars for people that are starting with cloud computing in AWS. We're working on our next series, which is going to be dedicated to developers. So we're going to talk about serverless, we're going to talk about all the buzzwords that were in the previous slides of integration, continuous delivery, and many other topics. I'm starting, it's supposed to be community. I'm in touch with the Israeli community of developers and DevOps, talking with them, getting feedback, taking this feedback to our service teams. So if you have anything you want to talk with me about AWS in any aspect, reach out. I'll show you again the contact details, how to reach me. Very vocal on social media. Some can say too vocal. So I'm doing a lot of Twitter, doing a lot of Facebook. So you're more than welcome to follow me. I have a very long history of development. This is where I'm coming from. I'm coming from web development. I've been doing it for many years. In the last several years, I've been doing IT operations as well. I've been an AWS customer since 2009. That's a lot of time, and I've been a partner for several years before I joined. So I have some knowledge of the platform, but always happy to learn new things. Okay, so we're talking today about continuous integration, continuous delivery for serverless applications, and we are going to talk about the general concepts of how to develop a serverless application end-to-end. Our agenda is going to include some intro. This is going to be very, very short. People that saw my previous what's if this is the same one, whatever. If this is the same talk I've been doing previously in another meetup, I'm going to be talking with 2 slides about what serverless is and what Lambda is. Then we're going to talk about the development iteration of how to develop a product. And in this case, we're going to talk about serverless products, but I think it's something much more general. And then we're going to talk about serverless deployments, and I'll try to leave enough time. 45 minutes? 40 minutes? 40 minutes. So we have 40 minutes, and I'll try to leave some time to show you some projects that I did recently, and one that I did specifically for this talk. And so a bit of console, a bit of code, a bit of Git. Let's start. So, as I said, a very short intro about Lambda and serverless applications. Who's using Lambda here today? Who heard about, yeah, I know you're using Lambda. Sorry about that. Who heard about Lambda when he got the invitation from Ariel to join this session? Never used Lambda, doesn't know what it is? Okay, we're going to do it really, really quick. So the basic idea of Lambda is that we are taking everything that you used to run as your infrastructure and leaving you with only the code. You will provide us the code that you would like to run, and we will give you the infrastructure to run this code at any scale, and basically you can focus only on your business logic, only on what you're doing. Every Lambda function, function is the basic delivery methodology. To run it, you have to have some kind of a trigger, an event source. And there are more than 15 different event sources at AWS. Some examples for event sources, as you can see here. So, for example, changes in databases, requests to endpoints, or changes in resources state. I'll give you 2 examples. Uploading a file to S3 for storage. This is an event. Changing a record in DynamoDB. This is another event. As a result of them, you're basically invocating a Lambda function. And we support today Node.js, Python, Java, C#, and Go, as of last week. And then your code will run. Go. This is something. And then we are running your code for you, And this code can execute whatever, whatever you wrote there, and it can access external resources, it can access external services, and basically, when it ends, it will return some kind of a response and will go away. The basic idea of serverless is that, first of all, there are no servers to manage, and there are no servers you can access. This is one of the challenges we're going to talk about later when we're going to talk about the development process. It will scale with usage, so we will take care of the scaling. You can have Lambda function runs twice a day, and it's fine. You can have a Lambda function that runs a million times a day, and we will take care of the scaling behind the scenes. You're never paying for idle time, so you're running the Lambda function twice a day, you're going to pay only for those 2 invocations, and there is no cost for holding or storing the Lambda on top of our services. And high availability, full tolerance is built in and part of the service we are providing. And you have to remember this is a very new technology. We're talking about a technology that has been in production a bit more than 2 years. Okay? So a lot of the things we're going to talk about here might seem a bit new or premature, but this is something that we are still building. It's us, it's our ecosystem, it's our partners. But we already have some pretty amazing success stories. So I want to talk about FINRA. FINRA is a company that does trade transactions, stock trade transactions. They switched the transaction engine to Lambda about a year ago. They're running 500 billion of validations on stock transactions daily. Okay, this is an amazing number for something like Lambda. And what they're saying right now is that since they moved to Lambda, they see 2 things. First of all, it takes less time. The other thing is that the cost is much lower. And the most important thing is that scalability is not an issue anymore. They used to work really, really hard to support those 500 billion transactions in the previous infrastructure. And right now, scalability is not an issue anymore, and the system will scale based on the demand coming from their customers. So this is just one example, and there are a lot of other examples of our customers using Lambda. By the way, no need to take photos of the slide. I'm going to share it anyway after the talk. So if you want, you can take photos. You don't have to. Okay. This was about Lambda. Let's talk about developing serverless applications. So application lifecycle management for serverless application looks more or less like every other software project. We have the authoring part when you're writing your code, then we have the build part. I like this screen, I'll do it here. We have the build part when we're basically doing build, testing, and then deploying to production. But if I'm looking from the developer perspective, it looks slightly different. At the beginning of the process, I'm mostly busy with writing code, testing code, debugging the code, and then fixing the errors, testing it again, debugging it again, and so on and so forth. And this is how my day-to-day process looks like, at least at the development stage. All the other parts of the CI/CD, we'll talk about them later, but my development stage looks like this. Writing code, testing code, debugging. And then, if I have a pretty simple project, and some of the Lambda functions are very simple. In many use cases of Lambda, like for example, managing IT infrastructure, or running reports, things like that, it's a single function, maybe several functions. And there is no huge team that you need to synchronize between, and there might be a code repository, but you don't have to have a code repository. And the simplest way to author or to create this process is basically using the console. Okay? We're providing a console in the AWS console for Lambda, and it has a lot of tools that will allow you to run and test and write a very simple Lambda function. And this console was improved dramatically at reInvent, the event several months ago. It was only several months ago. in Las Vegas. And we added a few very interesting features. I'm going to go really quickly. We're not going to stay on this level too long. But first of all, we integrated Cloud9 editor with the Lambda console. Cloud9 is our new web-based IDE, which I'm going to talk about a bit more on the second part of the talk. It has graphs per function. You can basically see requests, errors, drill down. All the monitoring part is much more advanced. You can have several test events. This is very important for Lambda. Once again, I'm going to talk about in more details later. And the monitoring is much easier. Okay, you can jump to very specific timeframes, and the entire process of writing a single function inside the console is much nicer now and a lot more and much easier to understand. You can see in very easy way the flow, what's the trigger, what's the function, what are the permissions. You can go edit your code, you can test it, you can see the output. Real fun, but this is good for relatively small projects. And then, when you have a larger project, you're basically dealing with two things. And when I'm talking about larger projects, I'm talking about real application built on top of Lambda. And there are more than one developer working on them. There is more than one function. And it's becoming a bit more challenging. Let's see the other one. So when I'm dealing with larger applications, I'm basically dealing with two things. On one end, I'm dealing with my code. Exactly the same as before. I'm still writing my code, any of the supported languages, and I can do it in any IDE I want. But then I need to deal with the application itself. I need to deal with the application itself because it's not only the code. It's the connections between the functions. And it's the other resources that I need to consume or use as triggers to be able to deploy Lambda or large Lambda projects to production. And this is where it's become a bit more challenging. And exactly for that, I would like to introduce you. You know this guy? Sam. Okay? So Sam is serverless application model. And is basically, this is one of the solutions to manage and deploy large serverless applications. Now before I move forward, I have to say there are others. And they are pretty good. I'm using serverless a lot. It's another framework that is very popular. And there are other projects that are dealing with deploying Lambda function to AWS as an application. I'm going to focus on SAM because it has some very unique advantages and it's really well integrated into AWS. But the same concept I'm going to talk about here with SAM, you could probably use with other frameworks. So this is going to be the one we're going to use today. But take into account you can choose other frameworks as well. So basically choose whatever works for you, whatever makes sense for you. So what is SAM? So SAM basically is an extension of CloudFormation. Are you familiar with CloudFormation? Okay, I have a very short slide later on. But basically the idea of CloudFormation is to take an environment, describe it in code. And this is what we do with SAM. We're basically describing with CloudFormation a serverless application. And you can manage different types of resources. You can manage your functions, you can manage your APIs, you can manage your DynamoDB tables. But because SAM is an extension of CloudFormation, in theory, you can deploy any AWS service that is supported by CloudFormation, and it's more or less all of the services. I'm saying more or less because usually new services take some time until they are integrated into CloudFormation. But if you need to deploy an EC2 server together with your serverless application, I don't know if it makes sense, but you can. If you need to deploy a relational database, if you need to set up your VPC or anything like that, you can do it as part of your deployment process with SAM. So you're not limited only to the components of your serverless application. This is, by the way, one of the problems other frameworks has. So take it into account. And it's an open specification, and you can find it on GitHub. So you can download SAM, the source code of SAM to your computer. You can actually do pull requests to introduce new features, whatever you want to do with it. A few words about CloudFormation, if you're not familiar with. So basically, it's a piece of code that will provision AWS resources. And this is the basic idea of infrastructure as code. If you ever heard this term, the idea of managing your infrastructure the same way you're managing your code. You basically have a definition file of your infrastructure, and you editing it and committing it to your Git repository or to any code management tool you have. and treating your infrastructure exactly the same way you're treating your code. In our case of SAM, your application is basically converted into a CloudFormation stack. This is the output of running a CloudFormation. And it's a simple YAML file. I'm going to show you a few examples later. When it's short, it's pretty understandable. But take into account that CloudFormation YAML files can be huge. And in some cases they are. By the way, it's supporting JSON as well. So if you prefer JSON or not YAML, you can choose whatever you want. I think my examples are JSON. But take into account that it can become very complex very quickly. If you're staying...
hierarchy, right?
Yeah, you can do hierarchies and you can include other files and a lot of other things. But just take into account that if you're not staying on the level of your serverless applications, like serverless functions, API gateways, and you're starting to include additional resources and you want to build a good CloudFormation template, something that will work in all regions and take into account all kinds of scenarios, it will be pretty long and pretty complex, but very, very powerful. So this is what we're getting from SAM. And if we're going back to this, so I'm writing my code, I'm controlling my application with SAM, but what about the other things? What about test and debugging? How do you do that? And that was a really big challenge. If you're doing Lambda for more than a year, doing testing, doing debugging is a huge challenge for Lambda. I've been writing to log files at the beginning and creating all kind of interesting stuff. It kind of reminds me end of the 90s when I was doing web development and there was no debugging tools and almost no IDEs. So everything was basically an output to the HTML. I felt like this at the beginning. So how do we solve that? So there are several challenges you should take into account when you're thinking about testing serverless applications. First of all, you don't have a server. And when you don't have a server, and you want to have a testing environment that is more or less like your production environment, you're running into challenges around which OS should I use? What are my libraries? What's the runtime I'm using? Okay? And to have a place that I can count on those tests and have reliable debugging, I need something that is more or less the same on my local environment than the one we're going to be using when we're going to launch it into AWS. And the other thing, you have to be able to use the same limits you'll be using in production. I did not mention this before, but every Lambda function has some limits that you define. The first one is memory, how much memory this function can consume. The other one is timeout. When I'm testing something and it runs for 7 minutes and the maximum time, execution time of Lambda is 5, that's a problem. I need to be able to have this type of functionality on my local testing and debugging environment. Of course, all the response of the function, the logs, and all the outputs is something else that I need to be able to collect. Usually when you're doing it in production, when you go to CloudWatch logs, you need to have something locally that will work more or less the same. The other challenge is that I need to be able to generate events easily. And this is not that simple. Right now, internally in AWS, we have 15 different types of triggers to Lambda. Each one of them is different. The payload of the trigger looks different. It's very different to look at a trigger coming from S3 and then compare it to a trigger coming from, I don't know, DynamoDB or something else. And this is only the internal ones. What about API gateway that basically can transfer anything from an external application, and any developer can basically come up with his own schema. And I need to be able to work with different type of events, and I need to be able to trigger them in a very simple way. So those are the challenges, and there are two ways to do it. I'm going to talk about the first one really, really fast. You're more than welcome to try it, but it's a lot of heavy lifting, and I do not recommend that. I'm going to talk about the other method which will make your life amazing. Okay? So the first one is SAM local. SAM local is basically a local implementation of SAM that you can download and install on your own machine. It's a CLI tool. It will allow you to do testing and debugging of your serverless application locally on your machine. It will use Docker to mimic a kind of a Lambda execution environment. So you're getting really, really close to what we're doing in production. It will emulate your Lambda Functions API. And you can basically have all the events and the logs coming to your machine and use them as you wish. You can generate those events with a very simple command. This is just one example. If you want to generate an event that is coming from an S3 bucket, running a command, you're going to have an event that you can use to run your application. You have all the logs. It supports live debugging. Basically, it supports the port you can connect to and use debugging. And it currently supports Java, Node.js, and Python only. Okay, but I assume Go is going to be added pretty soon. And it's open source, and we are accepting pull requests, and you can go to the GitHub repository, check the code, download it, install it manually, or you can just do npm install AWS SAM local and have SAM local on your machine and start working with it. So this is one way. And this is pretty complex way. It's working with your command line a lot. You're in charge of setting it up. You're in charge of generating the events. And this is relatively complex, although it has some advantages. It's local, it's on your machine. It's pretty lightweight and has a lot of functionality you can use to have, basically to have testing and debugging of serverless applications. The other method is using Cloud9. And Cloud9, as I said before, it's a cloud-based development environment we introduced to reinvent. And basically you're getting an instance on AWS, a real virtual machine that we install all the tools that you need to edit your code, and it's running SAM local on this environment and exposed to you a very simple way to execute, to test, to debug your functions. So instead of setting up your local environment with those tools, running them manually, you're getting all of these from Cloud9, and it's very optimized for serverless, although you can use it for any code project you have. And I'm going to show you in a second how we're working with this and what are the advantages. So basically those are the two ways to test and debug. And if we're going back to this, so we solved the authoring part with SAM, we solved the test and debug part with SAM local or with Cloud9, and now let's talk about the deployment, the CI/CD part. So if I'm done with writing my code, the next step is to deploy to production. And for that, I can use several techniques and several tools. And the source part, you can store in GitHub, you can store it in Amazon S3, you can store it in Code Commit, which is an Amazon version of GitHub that is private. So you may consider using that. The build part can be used with AWS Code Build, which is basically a way to execute commands, take your source from one place, take something else from another place, create some artifacts, and then send it to testing. Testing can be used with Code Build or with third-party tools. We are supporting several third-party tools for testing. Choose whatever works for you. And the last part is the deployment. Basically, the output of this entire process is a CloudFormation template. And when you deploy this CloudFormation template, your serverless application will be deployed according to definitions in the YAML file from the beginning, which was part of the build process, and you're done. And this is how it looks like. And as I said, I want to leave some time to do some live demo and to show you how it works in real life. So I built an application. You've been talking to me in the last few weeks or been following me online. You probably saw me asking people to test this application. I created a chatbot. I created a chatbot using AWS Lex, which is a chatbot engine that is based on the same engines that we're using for Alexa. This bot is asking for people coming to my talks to rate my talks. And you're going to do it at the end of the session, right? After we fix the bug that I have right now in my talk. So this is the bot. You're going to the bot, you're talking to the bot. Each time you're saying something to the bot, it will send whatever you said to a Lambda function. This Lambda function will analyze. Basically, the bot will analyze your input. The Lambda function will get some parameters based on what the bot understood. It will go pull data from DynamoDB. The data I'm pulling from DynamoDB, it's the list of my sessions. Okay? I'll give you a list of my sessions. You choose the session you want to rate. You're going to give a score between 1 to 5. Once again, everything is between Lex and Lambda. And when you confirm that you want to give me 5 for the session of CI/CD of serverless applications, and you confirm that, the Lambda function will write to Amazon Elasticsearch that is running as my data store, because it's very easy to go to Kibana and then show nice reports, although I'm not at this part yet. I'm not a huge Kibana fan. But basically, when I'm done, I'm writing to Amazon Elasticsearch, and I have a repository of all the scores of all my talks with a lot of statistics about where the talk was. I can basically track people that were on my talks with the Facebook ID, and so on and so forth. Everything is the privacy policy. You can read from Facebook. It's okay. They make you do it, so I don't have a choice. So this is the part of the application. What's happening in terms of the CI/CD process? So I'm authoring with Cloud9. Actually, I can do it with any ID on my laptop as well. It doesn't really matter, because at the end of the process, what I'm doing, I'm committing my changes into Git. It's a public repository. You can find it in my GitHub repository. Let's go to GitHub/anyone. And when there is a new commit, basically there is a hook that will start this entire deployment process. I'm showing here one option, which I'm not using. And this is basically defining an AWS thing called build process that will send the results into code deploy, and everything is managed by code pipeline, which is basically defining the stages inside my continuous delivery process. Why I'm not using it? Because there is an easier way, which the result is exactly the same. I'm using CodeStar. And CodeStar allows you to start a software project and have all the components behind the scenes integrated for you in a click. I'm basically saying, I'm starting a project in Python or Node.js for serverless. From that moment on, CodeStar will do everything I need. It will create a repository on Git. If I'm using Git as my code repository, it will create a code build, it will create the code deploy, and it will show me a very nice UI with all the steps. It will even connect to my Git and show inside the same UI all my commits, all my issues, and then you can basically onboard additional developers to the same project, and they have all the definitions in one place, and they can start working on your project in minutes. Okay? So you can use both ways. The outcome is exactly the same. This part, you can define it manually, or you can define it by using CodeStar, and CodeStar will define it for you. Good enough? Want to see a demo? Yeah. Okay. Let's see if I can do a demo.
We'll see.
Okay. Yeah. A bit more beer? Okay, so at the back, can you see this? Okay. I assume this is what you want. Okay, so this is Cloud9, and this is my ID. This is when I'm working on my files. You can see on the left that I have my disk. Okay, this is basically the structure of my hard drive. I can go to different folders, I can add folders here, I can upload content, and because this is a real machine, I even have Bash console. I can do here whatever I want. Go to a directory. I'm working now on AWS Rate My Talk. By the way, it's auto-completing with tabs. The experience of working with this terminal is exactly the same as working with the terminal of my Mac. I assume if I do shortcuts and stuff like that, it will be stored here. So right now, you can see this part. So right now, I'm basically inside this folder. I can list it. I can go and do git status. Yeah, I modified something. Oh my god. Okay, and basically, the way I got to this place is going and doing a git pull from my repository into this environment. That's it. I got an empty box. I went to my dev environment, and inside this folder, did a git pull from the URL of my repository, and I have it right now inside Cloud9. What can I do with it? Tons of things. So first of all, right now I'm inside a Python project, and I'm saying that because debugging right now is not working for Python. You can only execute your code, you cannot debug. But I'm going to show you Node.js in a second. You can actually debug Node.js in the console. So I can do changes here, and I want to show you my application for a second, because there is a bug in my application. So.
Probably the return false. Probably the return false. It's a bug.
Yeah. So, the name is not the user, but fix it in a second. So this is my bot. Let's say hi to my bot, and I can ask for help to tell me what to do. I will say I want to rate a talk. And it's not working. Yes. Okay, so I asked him to write a talk, and it went through my Lambda function, went to DynamoDB, bought the sessions, and displayed me the sessions here. And there is a limitation for Facebook bots. You can't show more than, this is called options or cards. You can't display more than 3 cards. You can't display more than 50 characters, but it is what it is. And basically, I got here 2 sessions: cloud security challenge, which is challenges, and CI/CD for AWS Lambda, which is the session we are sitting in right now. And more options. I can click more options and it will go and bring me more options. There is a bug. You know what the bug is? The bug is that the talk cloud security challenges is next month. And it's not supposed to bring it. Although it's inside the database, I need to limit the number of items I'm bringing based on the date. And the talk of CI/CD for AWS Lambda should be the first one. Let's go back to Cloud9. I'm going to run the same function at Cloud9. Just hitting run. Nothing happens. I need to be on the function. Okay. Remember, I need to provide events and inputs for the function. So I basically do an event and create an event here. This is empty communication for my bot because I'm just starting the session. So I'm going to use this one. There is execution results here, but I'm running out of space in this resolution. Now I can hit run. And I got my response. This is very challenging to show on the screen, but basically this is what is going back to the chatbot. As you can see here, it's already fixed. I have CI/CD for AWS Lambda projects and reinvent recap and more sessions. This is fixed because last night I went to one of the functions here. I can search and stuff like that, but I'm lazy. The get session function was changed to include instead of only public sessions and date larger than and equal to date. Okay? So this is basically already fixed. But I fixed it and I did not commit it. So I'll go here, I'm gonna do a regular git add. So I'm doing git add and git commit, fixing the issue. I'm not going to do a push for a second, because before I'm doing a push, I want to show you CodeStar. So this is my CodeStar console. And I created this project earlier on, but the only thing you need to do to create a project is to be able to connect to your Git repository, and that's it. From that moment on, it will create all the other things for you. Let me close this one. So what do I have here? I have the application endpoint, which is defined in my API gateway. I don't need it for this application, but I define it anyway, so it won't be that boring to have only the function. I have API gateway. Doesn't mean anything. I have the commits. Okay, you don't see my commit here yet. Okay, I have activity of my application, of my Lambda function. I have open issues coming from Git, and I have my delivery pipeline on the right, which means that each time there is a change in the source, this one will be triggered. Okay, it will pull the source from GitHub, it will build it into a CloudFormation template, and it will deploy it to production. So now, if I'm going back to my development environment, I'm doing a push. Right. This is something I need to do here. Not sure I remember the password. I do. Okay, it has been pushed. Now let's wait. I can refresh here, but it doesn't really matter. Yeah! So this one? Okay, this is my push. Let's give it a few seconds. I'm going to see what's going to happen to this part of the source. Basically, there is a trigger, and here you go. No hands. Pulling up the source from GitHub, the latest changes. We'll build it and we'll deploy it. Takes several minutes, so we're going to move to something else. We're going to check out about later to see if it fixes the problem or not. So that was the part. That was the part of Python, and I want to do a very short example with Node.js to show you how debugging works. So I have another example. I have a very cool Slack bot that I can basically go and say, where do you want to go? So predictable. So I'm typing weather Barcelona. It's going to a Lambda function with webhooks of Slack, bringing back from a weather service the weather in Barcelona for the next 3 days. With nice icons, sunny and cloudy, all this stuff. This is a very simple Lambda function written in Node.js. And basically, this is the code of this Lambda function. So in this case, I have a breakpoint. Okay? And I can go, and the same way I did run, the previous one, I'm going to run this one. By the way, here, I have a file called Lambda payloads. See this file? I'm basically creating the payloads inside the file, and then I can manage them much easily. I can change the payload here, so instead of Barcelona, I have Ramat Gan. This is the test I did earlier. So let us run it. Let's see. And you see we're getting a response. Basically, Ramat Gan Israel, rain, 14 to 11, blah, blah, blah. Very nice. Now I want to debug it. There is a nice button here of debug, for debug. I'm clicking debug, and running it again. And you can see I have a breakpoint here. And woo! I'm stopped at the breakpoint. Not only stopped at the breakpoint, the debug panel opened, and I can basically see everything that's happening inside my code. I can see the variables. For example, the event. I can drill down into the event. This is all I got from the event. For example, was all done. Weather Ramadan. So this is the text I sent from my bot, and I can step into, I can step over, I can just hit play and finish the execution. And here's how you debug and test your code inside Cloud9. Okay? As I said before, it's not working for Python yet. It does work for JavaScript and Java. So you can debug inside Cloud9 very, very easily. Let's see what's going on with our code style. Okay, we're already done with the build. You can see this is the right time. We're now at the deploy stage, so it takes some time. And now, if I go to my bot, actually I'm not sure it's going to work for me because I'm in the middle of the session, but let's try to delete it. Start over. To wait for it to finish. Are we doing the time? 2 minutes, right? Or maybe not. 2 minutes. That's 3 minutes.
Just did enough.
This is the repository. This is the repository for the weather Slack bot. This is the repository for the rate my talk. I'm warning you, I'm the worst Python developer ever. Don't ever look at my code, don't ever learn anything. I'm just making it work, not more than that. Okay, let's hope it's done. Now let's test it. It could possibly go wrong. I'll do the shortcut. I know the shortcuts. No. So it's not the latest version yet.
Looks like it takes some random now.
Yeah.
No, it's going to the third one. No, because it's in the more session loop. Let's finish the loop.
You remember the other one?
Yeah, I'm still in the previous one. But I'll finish all my slides and I can do start over. Yeah. Okay. So now it's working. As you can see, CI/CD for AWS Lambda is now the first one. There is no security, which is the one I'm giving next month. I think we're doing it together. It's the one in city. Okay. Back to the presentation. I'm finishing up. So basically, this is the end-to-end process. The tools I've been talking about, CodeStar, with all the other code sampling tools that are basically part of your CI/CD process, and of course, all the tools around Cloud9. You're more than welcome to go to the Serverless developer tool page. This is a great place to start learning about the different frameworks and different tools that we provide today for serverless development. And because I worked really, really hard on this chatbot, I really like you to go into this chatbot, going to boaz.ziniman.aws Facebook account, click on send message and start talking with my bot. You're just going to rate my talk, and it will give you the different sessions, and then you're doing the process on your own. If you have any questions, I'll be more than happy to answer them. If we have time, if not, I'm going to stay here and answer questions. Thank you very much.